With another electricity question, we've got measuring the resistance of a wire. Okay, as ever, make sure you have tried the question before seeing my answers. Okay, if you're ready to move on, let's get to it. So as I say, this is a really standard experiment. You should know these symbols. Okay, we've got a voltmeter and an ammeter, and we're measuring the voltage and current. And you'll have seen this many times before. This is all about looking at divisions. Okay, so we've got a 0 to 10, okay, and we're measuring somewhere between 5 and 6. We're greater than 5.5, 5.6, 5.7, okay, so our voltage here is going to be 5.7 volts. In the case of the current, I'm happy that this one's here, okay, we've got 0.10, okay, 70. Our arrow is pointing directly at 0.60, so there's a reason that I've underlined the 0, which is because we are making sure that we are giving the answer there to 0. Oh, I've just been given a chocolate bar. That's very kind of you. Thank you very much. Okay, now, so we've got our two answers there, 5.7 and 0.60. Okay. We're then, this is nice, guys. Come on. State the name of the apparatus used to measure current. It is a current meter. No, it's an ammeter. Okay, an ammeter, not an amp meter, please. Okay, ammeter symbol with a circle with an A. Okay, now we've got the student closes the switch and records the readings of the voltage immediately. Okay, explain why the voltage readings are taken immediately. This has come up before, and again, if you've done a couple of these questions, you'll see that when a big problem in experimental questions is the fact that resistance can change, or that I should say that heating occurs. Now, why is heating a problem? Well, it can change the resistance of the thing that you're measuring. So if I'm trying to measure the resistance of a wire, I turn it on, okay, I am going to change the value of the reading that I'm actually trying to make. Okay, so resistance can change due to heating of the wire. Please remember that. Okay, another thing that it can be is unsafe. It can cause overheating, thus melting of things. But I would say that changing the resistance here, because that's what we're measuring, that would be important. Okay, presume we've not yet calculated the resistance. There, hooray, we're going to calculate the resistance. Okay, it tells us how to calculate it. But here's a nice point. They give you two marks here. Now the first is simply for getting your number, 9.5, given in this case to two significant figures, because these numbers are given to two significant figures. But then there's another bit here for the unit. Okay, remember CIE is trying to make these questions all add up to 20 marks, okay, for physics. So they think of little things that you can do to get an extra mark here and there. In this case, nice easy one, you just need to make sure you've got the units ohms. You could also say volts per amp, but that's, I don't think, particularly great here. Let's stick here with ohms. So we're going to investigate if the length of the resistance wire affects the resistance. We should get a change in resistance. If we change the length, change the resistance. In this case, it's doubling or increasing the length should increase the resistance. Longer wires are harder to get through. The diameter of the wire must be the same, okay, to make it a fair test. Why? Well, if we change the diameter, we would change the area, okay, and if the area changes, then the resistance would also change. There's a relationship we don't use very much in the 0654 course, where you talk about resistance being inversely proportional to the area. In other words, if I double the area, I have a resistance, okay? And so that's what's happening here. If we increase the area, then the resistance would change. We want to know the effect of length on the resistance, so we don't want to change the area. Okay. Now here's an interesting twist on the questions about percentage differences. Okay, two values are considered to be equal within the limits of experimental error if the difference between them is less than 10%. Now, I think I've said this in a couple of videos now. This is something that didn't used to be stated. You used to have to know this, but CIE has gone a bit nicer now. They said, okay, let's just assume that everyone knows this. But now we're going to do something different. I quite like this question. We've got a diameter of 0.250. And it says here, the student measures the diameter. Calculate the smallest value of diameter the student measures that's within the experimental error. Okay, so what does this mean? I think the first time you see this, you wonder what is going on here. Well, let's try this. Our experimental error is 10%. So I can go above or below by 10%, and as long as I'm within that range, we can sort of consider the values to be the same. So in this case, I've got a diameter of 0.250, okay, and I'm going to say 10%. 10% above, 10% below. Well, 10% of 0.250 is 0.025. What that means is I can go up and down by this 0.025 value, but no more than that. Now in this case, the question is asking us the smallest value. So what I'm going to do is I'm going to take my 10%, whatever that 10% is, 0.250, yeah, and I'm just going to take it away from the original value to get 0. Oh, I made a mistake. No, I think I'm okay. 0.225, okay? Which means that the value there that I can have, the smallest value I can have, as long as, in order for this to be considered equal, is 0.225. This is a new version of that percentage different question. Usually what you get is two values. So for example, two values of the diameter, and they ask you, are these two values the same? And what you have to do is calculate the percentage difference. In this case, they're saying calculate the value, the minimum value of the diameter, which could be considered the same. So it's a slightly different twist. Quite a nice question, okay, but I can imagine it being one which trips people up. Okay, I think we're almost there. Oh, there we go. Two students doing an experiment with a similar resistance wire. Okay, aha, this is where yes, I'm glad this one's come up. When we've got this, with the results of the readings, here we go, voltage, 4.81, 4.83, etc., etc., etc. And then we've got student T for Tommy maybe, we've got 4.32, 4.48, 4.51, okay? The student S's data is more precise. Why? And this is where, on a previous video, I showed you a very similar question which was talking about accuracy. This is where I've got it right. Okay, there is a smaller spread or range in the values. When you've got a precise bit of data, there's a smaller spread. Okay, so you see there, in student S, you've got a small range from basically 4.81 to 4.83, very small. However, in student T, you've got different numbers, but there's a bigger range, 4.32 to 4.51. Now, there's a smaller range in our S than there is to T, which is why they're more precise. If you remember back, I'm sure you've watched my other videos, hint, hint, where they talk about accuracy. In a previous question, I got a little bit confused because I'd done the question too quickly. Okay, accuracy is about being the correct value. So if you had to judge whether something was accurate, let's say the resistance was, I don't know, 4.5 ohms. Okay, ask yourself this question. Who's more accurate? Student S or student T? We're saying the resistance is 4.50 ohms. Well, student T is actually more accurate because they are slightly closer to that 4.50. You can see if you average this data out, you get around about 4.4 something, which is close to 4.5. Okay, and so therefore T would be accurate but not precise. S would be inaccurate but precise. Okay, so precision about the range, accuracy is about being close to the value. This is something coming up again and again in our questions, so I want to make sure everyone's clear on that distinction.